All right, so if we think more about these multi-stage experiments, um, we have different situations. So say we have a situation where we have 3 balls in a box, 2 are white, 1 is black. Then if we're going to draw one at random, the probability of getting this white ball is 1/3. Probability of getting this white ball is also 1/3. Probability of getting the black ball is 1/3. So we could either draw our tree diagram like this, or we could combine those white balls together to say the probability of getting a white ball is 2/3, probability of getting a black ball is 1/3. So if we are going to draw a ball at random from this box and record it, then we have a couple of different options for what we do with that ball if we're going to continue drawing balls from this box. So we could replace the ball. So we draw one from the box and figure out what color it is. We look at it, we say it's either black or it's white, and then we put that ball back into the box. This is called replacement. So we would use a tree diagram to say, okay, well, I could get a black ball and then I could get a white ball, or I could get a black ball and then I could get the black ball again because I've put it back in. So the first draw is either a 1/3 probability of a black ball, a 2/3 probability of a white ball, and then we put whichever ball we get, we put it back into the box, and then we have the same probabilities for the second draw. So we have 4 different outcomes: black, 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 white, white, black, or white, white. And so the probability of the outcome we can find by multiplying those probabilities together. So this gives us the multiplication rule for probability of tree diagrams. So for any multi-stage experiment, the probability of an outcome along the path of a tree diagram is equal to the product of all the probabilities along the path. So let's think about a different possible scenario. In the scenario I just talked about, we put the ball back in after we record its color. However, we had a different option, which is we draw the ball, we record the color, and then we leave it out of the box. We don't put it back in. So that would be without replacement. So if we are not going to replace the ball in the box, the probability of what we get for the second draw is changed, because say we first draw a black ball, then the probability that we drew a black ball in the first draw was 1/3, and then we do not replace the black ball. Remember, our original experiment had 1 black ball and 2 white balls. So if we draw a black ball to begin with, then we are not going to put it back. That means the only possible outcome of the second draw is this 2 out of 2 probability of getting a white ball. Now, if we draw a white ball to begin with, then the probabilities change, but it's not certain what's going to happen next. If we draw a white ball, then we're left with 2 balls, a black and a white, and the probability is equal of getting either of them. So the probability of drawing a black for the second draw is now 1/2, and 1/2 for a white ball. So again, we can follow the probabilities along each of these paths to see, okay, what's the probability of getting a white and then a black? It's 2/3 times 1/2, or 1/3.